1.2 Introduction to Theoretical Probability. So theoretical probability is the probability based on analysis and reasoning rather than experiment. Okay, so it's equal to the number of favorable outcomes divided by the total number of possible outcomes. So for example, tossing a coin, it's 50% heads, or 1/2, right? 2 outcomes, and there's 1 head, and 50% tails. So there's 1 tail, and then again, 2 outcomes, heads and tails. Okay, and again, the number in the universal set is NS, and the universal set is denoted by a capital S. This is used in well-defined and accurate mathematical principles, can be used in ideal situations, okay? So, for example, casino games, the probabilities help to set payouts. There's genetics, so predicting disorders and traits being passed down, or in astronomy, predicting occurrence of solar and lunar eclipses. Okay. And the sample space, formal definition, or the universal set is denoted by a capital S, and it's all the possible outcomes. Okay, we use set notation, so S equals, we use these squiggly brackets, and what we do inside the squiggly brackets is list all the outcomes with commas between them. If there is a logical order, then we put them in the logical order. Okay, so example 1, theoretical probability. A jar contains 20 marbles, okay? So there's 7 red, 10 green, and 3 blue. What is the probability of pulling a green marble? Okay, so probability of green is going to be the number of green marbles over the total number of marbles. So we can either count them over here, or we can refer back up to the question 10 green, okay? And we have 20 marbles in total. So the probability is 50% or 1/2. Okay, B, what's the probability of pulling a blue marble? Okay, so this is going to be the number of blue marbles over the universal set, which is the total number of marbles. So this time we get 3/20. Okay, C, what's the probability of pulling a marble that's either red or green? Okay, so we're back to this or. Or is 2 different outcomes, and we are going to add them. Okay, pulling a red and a green marble at the same time when we're only pulling 1 marble is not possible. So we're going to go probability of red or green, and what we're going to do is we're going to add the probability of a red plus the probability of a green. Okay, we can use this number notation, or we're going to just skip this time to 7/20 plus green is 10/20. Which gives us 17 marbles out of 20 are going to either be red or green. Okay, and then D, a marble that is either green or blue. So green or blue is going to be the probability of a green plus the probability of a blue. Okay, logically, you could just count green or blues, whichever one. So all together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, green is 10 out of 20, and blue is 3 out of 20. And that's how we get our 13. Okay, and then E, what's the probability of pulling a purple marble? Okay, well, it's the number of purple marbles over the universal set. Well, there's no purple marbles in there. So this is going to be 0 out of 20, which is just 0. So this 0 actually means it's impossible. Okay, now let's touch on the expected number of outcomes. So to find the expected number of times an event occurs, what we do, so for example, the expected number of times that event A will occur, what we do is we multiply the number of times we're completing the actual experiment, so the number of trials, by the probability of that event occurring, so the probability of A. Okay. So if a single 6-sided die is rolled and it's numbered 1 to 6, state all possible outcomes of this experiment. Okay, so first the sample space is going to be 1, 2, 3, 4, 5, 6. And those are all of the possible outcomes. And now we're going to go determine the probability of rolling an odd number. Okay, well, how many odd numbers are there from 1 to 6? Well, there's 1, 3, 5. Okay, so there's 3 of them out of 6, which is a half. C, determine the probability of rolling a 5 or a 2. Well, how many 5s or 2s are there? There's 1 5 and 1 2, so that's 2 different possibilities out of 6, which is 1/3. Okay. D is determine the probability of rolling a number greater than 2. So strictly greater than 2 does not include 2. So it's going to be 3, 4, 5, or 6, if you're thinking about that. So there's 4 possibilities out of 6, which is 2/3. And now determine the probability of rolling a 7. Well, there's no 7s. If you take a look at the universal set, there's no 7s. That's 0 out of 20, which is just 0. Okay, it's impossible to roll a 7 on a 6-sided die numbered 1 to 6. Okay, and now F. Determine the expected number of times you're going to roll a 6 when rolling the die 50 times. So the expected number of 6 is, we're going to sub in the number of trials, which is 50, times the probability of actually rolling a 6 is 1/6. So we simply do 50 divided by 6, we get 8.33.